Let me just, you know how it is, I've got to double check.
Yeah,
Just got to do
I
that.
don't want to do it twice.
Because it says it's streamlined. Yes. Still.
It's glitching, is it?
Yeah, it's glitching. Don't know what's going on. But anyway, we're recording it. It's good enough. The audio comes through. Over to you, Mike.
Okay, well, thanks. Good to see everyone here again. Thanks for the invitation, Al. Great to be at the event. Health warning: I'm a techie, not a presenter, so don't expect the polish of the previous sessions, but I'll do my best. So we're going to talk a bit of a shift in topic here. We're going to talk specifically about mobile in relation to sort of IoT and enterprise style applications. So, for way of background, and set the scene a little bit. You know, we live in a mobile culture these days. The mobile networks have become sort of the fabric of society in some ways. It underpins so much more than it used to. It's a real fundamental part of the infrastructure that we all depend on. You know, mobile innovation is typically dependent on two different things, two elements. You've got the platform, which serves a particular vertical or particular need, and then you've got the connectivity to get to that platform. Those platforms often reside in the cloud, and when I talk about cloud here, I mean in sort of a hyperscaler, infrastructure as a service, platform as a service, AWS style. And those platforms are very agile, they're programmable by definition. They've been designed to allow, as a platform, to build things on top of. You know, they're good for developers. You know, they're very observable, they're accessible, they're open, they're democratized. Anyone can use them to whatever scale they need. But the connectivity to those platforms in lots of applications is based on the traditional mobile networks, and you know that isn't agile. You know, it isn't self-service. It isn't flexible. It's a totally different, different ethos in the way that those things have been built. So why is that the case? There's some historic reasons, some technical reasons. You know, what can be done to change that perception, and how are we going about it in our project? So the reason for the difference, there's a few differences. I mean, the hyperscalers and the cloud providers, they were designed to be platforms. They're designed to be technology which others build on top of. Whereas the mobile networks were designed to provide a service. You know, it's a different start point for the sort of requirements. The hyperscalers aren't really burdened with much legacy. You know, the technology has been built over the last couple of decades, layer upon layer, with no real historic constraints. But the mobile networks have got 40 years of legacy. We're on 5G now, and all those other Gs. There's lots of legacy which has been carried forward, and we'll look at that a little bit on the next slide. The hyperscalers have got a lot of architectural freedom. They can build their networks and roll it out as they see fit to meet the needs of the markets and the customers, whereas mobile networks are quite tightly defined. There are norms, there are standards, there are architectures which almost every operator has to use practically, which does constrain what can be open and what has to be closed. The hyperscalers, as I said before, built for innovators, built as a platform. The networks are built really for end users primarily. Cloud is about democratization of control, APIs, automation, orchestration by the users, by the customers, whereas mobile networks are designed to be controlled centrally by the operators. And the interoperability requirements for cloud. I mean, a cloud platform sits on the internet. It needs to understand DNS, HTTP, the basic protocols. Not much more than that. Whereas mobile networks, particularly through roaming, the connectivity, the signaling between those networks has to be very tightly defined. It's become very, very complicated. and each generation of technology makes changes to that, which adds complexity rather than takes it away. And the standards behind the test, the standards that we emerge through the community, whereas mobile networks have to adopt data standards which are essentially regulation defined by GSM in a quite complex and tight way. So the 40 years of legacy of mobile, we are on 5G now. We've gone back from the old 1G, if you like, analog A phones, worth a fortune on eBay now, right through to modern high bandwidth platforms. But there's overlap between these phases technically, backwards compatibility. So when we're over here on this side of the model, there's technology still back from 2G, 3G still has to be supported. It's difficult to be real. The services provided to users have changed over that time, and also we've been able to change from what was originally a peer-to-peer calling your friends technology to something which is a lot more M2M and IoT centric. And on the technical side, I won't go through this in detail, but there's almost a blueprint for how to build a mobile operator. There's particular building blocks with their own acronyms, their own standardized interfaces that's evolved through those generational steps. And there's standards for how those platforms talk to the rest of the world, and those are really important. Without those standards, you don't have interoperability, roaming doesn't work. That stuff's really, really important. But in the middle, there's also a lot of standards which are within the network. And the purpose of those standards really are about procurement efficiency, being able to buy an HSS from Nokia, a packet gateway from Huawei, they'll talk together. So these, right from the vendors, they're all quite similar to one another. They're black boxes. They're well understood, designed to get inside of. The lids are tightly screwed shut from a developer's perspective. It's a very much a model built on layers. It's not really historically been a service-oriented architecture. It's difficult to get under the skin of this stuff. It doesn't lend itself to democratized control. There's data duplicated all around this architecture for different purposes, not for this customers. It's functionally distributed. Although it's proved to be a good model up until now, it's all about the operators keeping control. So how does that, as a developer, the differences between these? So I've taken an example here about a developer who wants to create a virtual private slice of connectivity or private network. And in the cloud world, that might be a VPC. It's a network which you can create very easily. On the mobile networks, that as it's called, which is a private layer 3 connectivity to get your SIMs to your back end. So on the cloud up in the morning, we're halfway through our pizza, we decide we need a virtual environment, we log on to the AWS portal, a few clicks, click go, a couple of minutes later we've got a new VPC, we start paying monthly a few dollars for that connectivity. It's all under our control. On the mobile side, if you decide up in the morning, well, good luck, because this goes through a very engineering risk management process with quotes, service orders, takes weeks, costs thousands of dollars. It's a very coarse chunk of functionality. You can't do this many times for small applications. It's no approach, very different from what's in the cloud. So what we're trying to do is how do we take all the flexibility that developers have got used to on the cloud back to mobile networks to give them the same sort of experience. So there's quite a few vendors who've had a go is to build sort of a service exposure layer across the top of the core network. Use the APIs, which may be proprietary APIs, building blocks, expose, use or abuse some of the signaling protocols which are defined by the standards for other purposes. It's a pretty non-disruptive way to go about it. It's pretty easy to take the standards network and you're just wrapping it up. But it does mean that the actual functionality that the developer gets access to, these are the APIs, which the way these are normally exposed is largely about SIM lifecycle, turning things on and off, being involved in the SMS flow, looking at diagnostics, finding new ways to charge and make money out of the traffic. Nothing really particularly innovative, nothing on the same stability that you get on cloud. So what we're trying to do is a totally different approach. So we're trying to build a programmable mobile network. So a mobile network which is designed with the developer as a first-class citizen, to think about, as a developer, what functionality do you need to deliver your solutions to resolve some of the challenges and the issues that are there at the moment, rather than being constrained by the typical mobile network architecture. So we're trying to apply sort of CPaaS principles and C+ techniques to the mobile core network, designing a network as a platform rather than network as a service, with a view to democratize and control configuration, observability, etc., in the same way as you go. At the same time, we need to make sure that what we build complies with these interoperability requirements so it can still talk to the rest of the planet. We need to protect the network from bad actors and disruption, and we need to be mindful of what fraud opportunities this could open up that we need to mitigate against. How do we want to do this? You know, as a developer, what could you do in this way which you can't do today? Well, security is first on the list, you know, for good reason. Security, particularly in IoT, has become a real hot potato at the moment, a real hot topic, and the need to be able to tie down device behavior and connectivity away has become really, really important. So this allows the developer to be very, very tight over what hosts those devices can talk to, in what circumstances, spot anomalies, spot things which are unusual, manageability, to be able to take, if you've got lots of IoT devices at the top of lampposts, it's very difficult to change the configuration on those devices. You can bring some of that intelligence into the network, it means it's a lot easier and a lot much more straightforward to integrate with. Observability, watching what the devices are doing, spot roaming behavior, mobility, spot what traffic's being passed around, mirror traffic to AI-based platforms for spotting traffic anomalies and security. Getting involved in the roaming process, as it's steering, as it's called in the mobile space, being able to make real-time decisions embedded in the application which controls how devices move between networks. Geofencing, spotting when devices change between different technologies. Again, this opens all this up. And being allowed to integrate with devices and manage them as if they were on your network rather than scattered around the world. Make the integration seamless rather than very complex processes that often do it. Agility, being able to make changes at 2 o'clock in the morning while you're halfway through that pizza, really, really, really useful. Being able to spin up multiple different environments, a different part of the software lifecycle, that's something which developers are used to and rely on it elsewhere in Eddie. Being able to make decisions about the way traffic is routed depending on where the devices are, from a performance perspective, for regulated software SD-WAN style configuration over mobile data. And monetization, you know, charging for the use of these devices in ways which are better aligned with the vertical that they're in. We're using crypto-based charging by being able to inspect and control the way the data is passed around. And finally, the basic one, life cycle, being able to see what devices are enabled when, turn them on and off in real time. I could produce another 3 or 4 slides just with these points. The point is that there's lots of different, by getting control under the hood of the mobile network, there's a lot more we can do as deepest than we're used to at the moment. So, as security, that's what we're building. We're building the programmable mobile network. So how are we a work in progress? You know, this is a project we're probably about halfway through at the moment. So we're not trying to sell anything, just explaining where we're on our journey. Some of these things might change as we discover it. Is thinking about, as a developer, how do you want to interact with the tools and platforms that you rely on? And it's not about diameter signaling and SS7. It's not about all those telco-specific protocols that the mobile industry operates on. It's about RESTful APIs, GraphQL, webhooks, WebSockets, WebAssembly, all these sorts of tools that we're used to using in the cloud. We want to recognize the development processes that developers use these days. DevOps, continuous integration, all these sort of things that we're used to, which don't really work well in mobile. And we're going to try and make sure that developers can use the tools they're using today for development and apply that to the mobile core. Essentially insulate us as developers away from the esoteric telco technology which happens under the hood. So if that's one bookend, if you like, the other bookend is at the back end. Of course, when we talk to the rest of the world, we do have to adhere to all those standards and comply with all use all those protocols. So we've built out the telco protocol stacks, the way that operators talk to other operators. So in using modern tools and technologies. So we're not dependent on any third parties for that. Wraps up all diameter SS7, all the protocols that are used there, GTP. And by making sure that that's standards compliant, it means as we engage with operators to use their roaming agreements to get coverage and to globalise this proposition, there's nothing really special required from them. It's just a standard full MVNO model, as it's called, across space. And in the middle, if you like, the gem in the sandwich is we internally, as we're building this out, we're developers as well. We've all worked in operators, so we know we've seen the good and the bad. But we also want to make sure that our development cadence is quick. We can deploy quickly. There's not huge effort involved in rollouts and upgrades. So we're making sure that our technology in the middle is reliant on, containerized deployments, the partitioning and sharding around the data, an integrated data model. So we've, rather than taking a standard mobile architecture that we saw in the previous slides, we've thrown that out the window largely and built it just to use normal IT techniques and development techniques. I won't go through this in detail, but these are just a taste of some of the technologies that we're adopting in the middle. So, Kafka, timescale DB, Postgres, Mongo, Elasticsearch, it's all the stuff that most techies love in the cloud space. There's two fundamental bits of technologies which are really critical, which we've completed now, which is like what we call our interworking platform, which is like the translation between telco protocols and HTTP2 style protocols internally. If you know anything about 5G, 5G is based around some of those technologies too. And a very innovative, which effectively is a router, which allows programmable control over what packets flow where for what devices. DK, Rust, AFXDP, again, modern and very performant sets of tools. So, where are we up to so far? So, those interworking stacks for signaling are complete, they're working, they're deployed. That's allowed us to effectively prove the end-to-end mobility and detach SIMs. So we've produced SIMs which will now attach anywhere in the world, and as those SIMs attach and pass data, generate all the traffic up that the developers will then be able to consume and interact with. Our packet forwarding engine, the Rust platform, the router, is built and tested. We've got our first sponsor operator on board and integrated, so that gives us coverage over 650 networks worldwide for these SIMs. And we've successfully had signed off the end-to-end interop testing of all our signaling. So the bottom layer of that stack on the diagram before is complete, proven and tested, and now we're working on a bit in the middle. So the next steps, so we expect to get the full platform to MVP stage. We want to now engage with developers, we want to engage with people who understand what those needs are and how we can best serve them. To identify some early adopters, some pilot projects, maybe get involved in some TAD hack stuff, just to try and get them engaged with the community. Our DevRel platform and the process for that, we really want to get going, because we want to be seen as a developer-first business. We're developer-first business. I mentioned before about doing a great job of that in terms of documentation and training. We want to do that for the mobile core. We need to roll out the production platform from a scalability perspective. We aim to launch early Q3 next year. We'll be launching a beta program before then for anyone who's brave enough to give it a go, but that's when we expect to push applications. And we're also in parallel with that onboarding more operators to give us more coverage in different regions and different markets. So we're a small company, so 4 of us here, we're half the team effectively, come here today. And so that's why we're trying to be branded. Please track us down, talk to us. We're all techies except him, who's the marketing guy, but we let him come anyway. We want you really keen to talk to developers to understand the needs and to get feedback. The proposition is still at the shape that it can be shaped. We want to gather other people's experiences too about pain points so we can resolve them. Mobile operators, we're talking to many mobile operators who see this as an opportunity to recover some margin in an increasingly competitive space, deploy something alongside their existing core, which isn't disruptive to their business as usual stuff. So there's definitely a win-win there. IT aggregators and resellers of connectivity who are at times struggling to stay relevant because they haven't got differentiators. We'll talk to those guys too. Or if you're just curious to see how we get on and what we get right and what we get wrong, whether we keep our houses, then I'd like to chat to you too. So that's it. Thanks for listening. Any questions now? We'll have to.
So Adnan, if you can get yourself set up and just take any questions while Adnan gets set up. Of course, grab coffee, water.
Got you 5 minutes back, Alan, as well.
Laptop sometimes. Coming pretty soon.
Okay, so it's a 2-minute warning, Walter. Here you come, 2-minute warning. We're back.
Can we put our chairs here because the light is reflecting? The light is reflecting and we can't see very well.
I understand. Okay, so we're 10 minutes behind. Okay, time to take your seats. Everybody sit down. Joe? Time to take your seat, Joe. I know. Here we go. Let's get quieter. Everybody sit down. Give Adnan a chance. He's too busy. Okay. So let's sit down. 10. As I said, it is going to be intense. Okay, so I'd like to hand over now to Adnan. Over to you.
Thank you. Hi. Good morning, everyone. So quickly, I'm at Radisys, CTO Software Cloud Solutions. We're going to talk about communications and digital engagement platform that Radisys made available as a commercially available product earlier this year. Quick introduction. I'm traveling with a couple of my colleagues. Al Blasco, if you raise your hand there, Al heads the business unit, vice president of the business unit. I'm CTO in that same organization, and we have Ralph Page representing our account executive from our UK London team. So here I'm going to do the topic, as you probably saw from things, advancing cloud communications beyond the basics. So we're going to talk about what are basics, and I may use the word basics in a way that maybe offends some people, but the idea is not to say, well, this is basics and this is easy. Sure, there's lots of innovation and work going on in what we're calling basics. We're going to talk about what are we focused on, how is our digital engagement platform above and beyond kind of what has been in the industry in terms of basic calling and messaging. I've got to summarize it quickly like that. And literally leveraging AI and machine learning technology when it comes to real-time audio and real-time video. Kind of that's the focus area of AI machine learning from when we talk about digital engagement experiences. So what we call the basics there are, well, we've seen CPaaS, video calling, voice calling, peer-to-P, P2A, A2P, SMS messaging, two-factor authentication, all that kind of stuff that comes with it in a CPaaS, in a typical CPaaS deployment. Then we have some areas called UCaaS, group collaboration, multi-mode, omni-channel, then contact center solutions, again, around interactive voice response, contact center type of solution, right? Kind of put them all together, expose them to APIs, SDKs, developer community goes and uses them, creates enterprise applications, consumer applications, maybe in some cases even in-network applications. The key areas, of course, where the industry has gone over the last 10 plus years, since I guess Twilio days, is the developer community abstracting complexity. That's the main thing. Now a web developer, mobile developer can very easily, does not have to be a SIP telecom expert, does not have to know the underlying complexity of communication systems, streaming protocols, all of that stuff, right? RTP handling and RTCP and all that stuff. They have an API, they can quickly go and write applications, and they're all around communications based, right? In any kind of one of these three areas. Rapid development to deployment, that's obviously the key part of it. Be able to create applications quickly, launch them quickly. And then, of course, as you can do them more quickly, you're able to do more innovation. You don't have to spend 6 months building an application just to find out, well, it kind of missed the mark. So rapid development and more innovation. So this is what I'm calling the basics here. So what's beyond the basics then? So what's beyond the basics is around the same themes that make things that are consumed by the developer community. Things that are complicated that have already been exposed through APIs and SDKs in the communications domain, messaging, calling, P2P, P to application, application to P, and all the things that we talked about in CPaaS and UCaaS and CCaaS area. So what's beyond the basics here? So what we're talking about is digital experiences that are more immersive experience. And I'll kind of go through a few slides and start to get an idea of what do we really mean by immersive experiences, what do we mean by Industry 4.0 applications that are really leveraging these days complicated things when you're trying to do a computer vision model, for instance, or a machine vision model, and you need to use that model to create your application. How are you going to go and train that model? How are you going to use that model in real time? And when a certain event occurs that you've had a crowd control situation, I'll pick an example. You point a camera feed to this room here, and if it identifies more than 25 people, they say, okay, this is a crowd count limit threshold reached. Now you need to go and notify SMS message or whatever your business logic is getting you to do, but you need to have that AI machine learning algorithm as part of your application to create immersive experiences, whether it's for Industry 4.0 or whether it's for natural language understanding in the speech domain. So there's many combination of these AI ML technologies when they are applicable in the real-time media domain, real-time audio and in real-time video feeds. How does an application developer very quickly and easily create a computer vision model, a CPaaS-based application? So those are the fundamental building blocks that we're building into what we call our Engage Digital.ai platform. So if you guys go look at it, it provides all of what we're calling the basics that are the table stakes features, which are communications, messaging, calling, group calling, all the standard stuff that you would expect to see maybe in a or two like offering. But layered on top of that inside this platform is the ability, and again exposed through APIs and SDKs, a very easy to consume computer vision, speech analytics, video analytics very quickly. Can I give you an example that one of our developers did was language translation. So, and literally within 2.5 days of work, real-time AI-based real-time language translation. So somebody speaking German, the other side person speaking Japanese. Now that application can be developed in less than 2 days. Then people who've done computer vision applications that are also kind of in the same time, 2-3 day thing, you can do scene detection based on scene detection. So if those building blocks are not available as part of the platform, and if they're not exposed as part of easily consumable APIs SDKs, then people will not be able to go create these kind of more digital experiences. So that's kind of what our focus is, going beyond the basic application to leverage AI and machine learning technology as it's applicable to real-time audio and real-time video. The traditional building blocks up there was the programmable communications part. We call these blocks kind of the enablers when complexity has been built. And above that thing is, of course, like anybody else, we expose them through REST APIs and EML markup language, and we provide SDKs and things that are appropriate with Jumpstart. They will go and write iOS or Android applications, web applications, or literally embedded into an operator's network, and those capabilities become available because these through APIs and SDKs. So very similarly, what we're doing is this part here, the bottom part. Of course, this is only there's a lot more to it. The box will be, but there is AI, ML, computer vision, speech analytics stuff. Then is the same idea to take these complex blocks, build them as part of the platform, and expose them to the same set of APIs that web developers use. So somebody can go and create applications. I'll start to give you some idea of what type of applications can be built once these complex that require machine learning and AI modeling to be easily consumable by the end developer that does not have to be an expert. Just like they didn't have to be an expert in SIP, now they don't have to be an expert in data science and machine learning, because those things have been abstracted, complexity has been abstracted, and you've exposed them through APIs and SDKs. Areas. I mean, when we look at it, the underlying fundamental building blocks are very common. I mean, if you talk about in education, for instance, or you're talking about emergency response, or smart cities where you're doing crowd control, or you're doing something in health health area. A lot of those things are kind of similar building blocks from